So myself, Hemant Chourasia, I work with Qualcomm. I'm certified lab architect. Today's presentation is code optimization for large data set. So my current role involve like I'm in RF and signal processing. So dealing with large arrays, waveforms, time domain waveforms, FFTs, some 2 mega samples, 5 m samples. So right, so that's more that that's make us to to write a optimal code. Otherwise you'll see a memory leak or a dynamic memory allocation, you'll see a test time increased, right? So in the large data set we'll be mainly talking about, I'll be sharing you the examples. I'll show the how the times looks like if after doing a modification, if you are using a certain functions, how we can optimize, how we can avoid dynamic memory allocation, how we can increase our execution speed and all, right? So maybe everyone has heard about lot about don't use build arrays, don't use joining functions, join string functions and all, right? They do dynamic memory allocation. So basically what is dynamic memory allocation is in LabVIEW. So anything that LabVIEW compiler is like, in the runtime allocating a memory or maybe deallocating a memory, it's like back and forth. We need to allocate, we need to deallocate, right? In the runtime, that is like a dynamic memory allocation. So everyone is familiar definitely with build arrays and joining concatenate string. That makes that makes LabVIEW to allow to to allow or to allocate the memory in the runtime. So if you look under the hood, how what is dynamic memory allocation? Basically, the compiler has to allocate the memory, right? Even let's say if you talk about let's talk about the LabVIEW term, right? How we can say build arrays do the dynamic allocation, because a compiler don't know what is the output size of my array, right? So LabVIEW or compiler has to do it. Is need to allocate the memory. So right now I'm showing you example. I'll show you the example how we can. I'm showing you the test time also. So this is the simple code. Basically that gives me output like 1, 11, 21, 31. This is the simple code that I have developed for just for a demo purpose. So array size is 10m, right? So right now this is the code. Basically what I'm doing, I'm just using this quotient and remainder function and building this array to get the required output. So if I'll run this code, as you approximately you can see what is the test time is like, let's say 100 millisecond, right? So let's look at the code where a dynamic memory allocation may occur. First maybe build array, right? And this is where it may occur, dynamic memory allocation, because LabVIEW has to a runtime need to allocate the memory. So one we can identify, let's say the build array may cause or may increasing the execution speed, and other may not be. If it in this windows is like this question and remainder function, but if you have worked in LabVIEW FPGAs and all thing, maybe this function is also expensive or there, it may not execute in a one single cycle. So this is the one way I can get this output. This is, I'll again repeat it, my inputs is like from 1 to 10m is the array size, and this is my output that I am getting it, I want to require 1, 11, 21, 31, 41. So this is the first way I can do it. I have identified this is the may cause my execution to go slow. So this is the one way. There is another way. uh, I am enabling this time I am using uh, inbuilt function that is also like a LabVIEW primitive. Here I am using a conditional wire to build the array. So let's see how this performance of this function. It's pretty good in compared to maybe, or maybe it will pretty same, or you can say better than the build primitive function, right? So here if you see where it may occur, the dynamic memory allocation is here, right? So now, how, so basically to write a optimal code, if you're working with a large arrays, try to, don't do any dynamic memory allocation in the for loop. As a best practice, don't do dynamic memory allocation in the loop. and try to reduce the decision making in the loop, right? If you see under the hood, if you see assembly language and all, any decision making is also like a jump instruction, right? That may also increase our execution time. So this is my another code that may be pretty same or little better than the build array function. Now I'll show you the way that usually in my practice, in my development, I use it. So if you see this code, I am using uh, basically, if you see this code in the for loop, I am not doing any dynamic memory allocation. I am just reusing the memory. If you see how, if you think in terms of memory, let's say Lavio has created this array, has stored in some memory, then I am just reusing the same arrays back and forth. If you see, I am not doing any dynamic memory allocation. Even that quotient and remainder function, I have replaced with a counter, right? You see,
Hemant, sorry, there was a question in the chat. Could you please show the previous case once? I'm not quite sure which previous case.
maybe with the conditional, I guess. Is it
Is this the one you were looking at? No, he says no. The one before.
other? Okay, is this one?
Yes, okay, thank you.
Eh, I am not looking the chat. Maybe if some, I
Sure,
can
yeah,
take the
I'll read
questions.
out if there's any more questions.
Yeah, sure. So these are
Thanks.
the two way. Like generally, as a Lavi developer, we think okay, our code is looking very simple by looking at occupying less space, right? Neat and clean. We think okay, let's go with this approach. But the two method what I have showed, those are not the optimal way. Optimal way to implement if you are working with arrays, definitely. If you are doing any dynamic memory allocation in the loop, it will cause you the execution speed and the memory issues. It may cause you in the memory leak over the period of time. If you see this code, right, you'll see the how much time reduction I'll be getting it out with this code. So basically I have initialized the arrays before the loop, that is and just replacing it back and forth in the for loop. I have replaced that question and remainder function also with the counter. If you see this run, let's see how it is. You see the drastic improvement in the execution speed, right? This is because we are not doing a dynamic memory allocation. You see that, see the performance. You'll definitely, if you're working with a real-time operating system, if you'll do the dynamic memory allocation and all this stuff, you'll not really achieve your timing constraint. So see the improvement, right? Just basically not doing any dynamic memory allocation. So so this is the one example. We know like here the build arrays, but there are a lot of function under the hood that do dynamic memory allocation. Examples, if you delete from array, insert into array, all are under the hood doing the dynamic memory allocation. Try to avoid, if you are working with large arrays, try to avoid insert into arrays and delete from arrays. These are all these are all functions doing a dynamic memory allocation in the runtime, and it will create or it will slow down your execution speed.
So there was another question. If you use an in-place element structure, does it have the same speed?
So basically, uh, this replace array and this structure, you will get pretty same. Under the hood, both are same as far as I know.
Okay, thank you.
So basically, if you see, usually how I look is like anything. If you let's say closely look and insert into function, right? You'll see the size of array here is little less, and after inserting, definitely it will be a one more size, right? That means is somewhere in the compiler has to move the data back and forth in the memory, right? It means a dynamic memory allocation. Same thing if you talk about delete from array. Let's say if you have array size as an input of 10 element, output you are getting a 9 element. That is also Lavi has to completely allocate the complete memory. Even if it is from, if the input is 10, you are getting as a, after delete you are getting a 9 element. That is also Lavi has to completely reallocate the memory. That is also complete. It's a dynamic allocation. If you use these functions in your time critical loop, in you will not able to achieve your time constraint. This is the one example regarding the arrays. So now I'll talk about the strings. So I have this example. This is here also. Let's say the length of this string is around 87K length, and these are the headers, some headers, and in this I have a this header. This header I have need to basically search into the input header. After searching it, I need to replace this 99M with the 100M. So this example, and output should be again in the string. Input string, output string. I should replace this new header with this new value. This is the my problem statement. So there's a first approach that I have used is like I have this string, I am converting to maps, and then again converting back to the the string. So later on I'll come to where here may occur a memory dynamic memory allocation, but I'll run it once and I'll show you the time test time. So roughly if you see, it is like, let's say 6, or maybe it will be more, 10 or something, right? This is the first approach. I'll run it, maybe some 5s, let's say 5, 6, 7, right? This is the first approach. Here also, if you see, by a normal, as a Lavi doubler will think, okay, we are not doing anything wrong, it's good, right? And now the second approach is what I have used is the previous, the way I have showed you, like, initialize the arrays and replace and all. So now if you run it, previously this is the test time with this maps and all. Now I'll run it, you will see the, right? It's drastically from 6 millisecond to 1 millisecond, right? You see the execution time has literally, test time has giving you a better number now. So again, the approach, if where maybe the dynamic memory allocation, if you see this code, right? So first of all, there are certain like that is what a LabVIEW meant for. We don't know actually where LabVIEW allocate the memory or deallocate the memory. The control is or on is with the LabVIEW, a LabVIEW manager. LabVIEW decide when to deallocate, when to allocate, right? So we can't say exactly where, let's say this, I'm creating this I'm creating a maps and all. I cannot say after this function LabVIEW will deallocate the memories which has been created for this map. I don't know, right? So certain things, what as a best practice we can see, so where if you identify here which code is getting or taking a more time, you can say this, right? As we talk about a join function, because join function is, if you talk about like in the, this is in a string, right? It's not a predefined bytes. Byte may vary, right? It may differentiate, it will be vary. So compiler has to know how in the runtime only how many the memory size I need to relocate or not, right? So one thing, just for a quick debug, what we can do is like if you just disable that function, or maybe it will not be, but you will see, okay, some improvement you will see it, even if you are like removing those functions within the loop. Maybe you are not seeing right now. So the key takeaway from here, to get a good optimize, to get a good speed, or to have a less chances of memory leak, if you see this code, I'll just again show it. If you see in this code, I am not doing any memory, you know dynamic memory allocation. Once I allocated the memory outside this loop, I am just reusing it, right? Same arrays.
So there's a question about the profile buffer allocations tool. Can you comment on the effectiveness of that tool or so on
I
for
have
finding where you're
not
allocating?
used that much effectively that tool. Usually, maybe I have not required it. You just after following the best practices, I have not come into the scenario where I have to go into to profile it each and everything. But you can explore it and let me know if anything
There's a suggestion that Darren will be angry and a smiley face.
to work on that. So uh, this is the you know if you're working with the strings. Uh, so this is one. So this is the two thing that usually when I'll show you how, if you are, let's say this is the example that when we were doing a project using a dqmh. So if you are passing a large set of arrays between two modules back and forth, right? So there is another, like as we know, like in the C and C++, we have the pointers. Pointer is basically a location to the memory, right? Pointing to the memory. So in the lab, you also, if you are having handling a large number of arrays if you are send or you are passing data back and forth between two module, that is a heavy array or heavy memory size, I'll recommend, or as far as my best practice, always create a DVR, so that if you are passing a DVR from one module to another module or back and forth, basically, or just let's say DVR is a 4 byte, this much bits only you're basically sending it back and forth. So instead of sending large arrays, right, I'll suggest or I'll recommend to have just pass send the reference back and forth and read it appropriately in the respective module. This is about the large array. If you are passing back and forth within the, it's like an inter-module communication or inter-process communication, create a DVR and pass the DVR if you're talking between two module. I think yeah. So if you are using a DQMH or something, better to have a DVR instead of passing a large array. So this is just a small example that I have created passing this using data via DVR. So just a key takeaway from here is like if you are having a passing a large data set between two module back and forth within the block diagram within the inter-process or maybe intra-process, just have a DVR to pass it back and forth. So I have one more more you can say for this for loop. Maybe everyone has have used this option or maybe not. So basically this is the loop that I'm not doing a very minor operation, just incrementing it. So if you do this, the typical time is around, like right now it's like 20 millisecond rate. So there is an option that you can use for this, enable this for parallelism, right? So if you do this, you will see the reduction, right? So there is a you need to understand, it may not give the performance benefit of enabling this parallel iteration always. You need to profile it basically, because there is an overhead. Lavi under the hood need to the chunk the data and again need to combine it in the last after the for loop. So it may not be always will give the optimal result. So before using this feature, I'll recommend to do the benchmarking and all. So this is what I have shared. Maybe I have one question. Maybe it will be easy to, but I'll ask everyone: what will be the output and why? What will be the shift register out and why?
So what? There's a guess of 1.
Okay,
That's the only guess so far. 10, 11,
okay. What was the reason? Let's
0,
say
10.
okay. So factual. I'll run it. The answer is 10. Anybody can tell why?
Yeah, so a few people with 10. There's one of those people want to tell everyone else.
Answer
The
is
memory
10.
of the shift register is the
Yeah.
answer. Okay.
So how I usually look, let's say, okay, maybe I'm coming from a C background, so I try to look the things in the way the C usually do. So how basically the shift register is nothing but a variable. So here you are writing to a variable, and inside the loop again you are trying to write to the variable, but as the for loop will is not going to execute, this is just going to read the variable here. So that's why the flow is, and you are seeing the 10 number. Hope I have explained it.
There were a couple of questions earlier as well. One was about the DVR creation process, and if you could confirm that the memory is allocated during the DVR creation. And
Memory has been allocated during the DVR creation. Can you come again? Like I missed.
sorry, the DVR creation also causes memory consumption. Actually, that was answered also in the chat as a one-time process and not inside a loop, and therefore it's not a dynamic memory allocation.
Yes. So basically, like again, creating it will create in a first shot. It will create a memory, but again, if you deep down, you'll ask me about when it will deallocate or when again it will allocate. It's something that I think Lavi knows better, far better. Lavi has a control on that.
And then the other question was, if you have large arrays, how would you recommend inserting or deleting from those arrays efficiently?
Sorry, I missed. Where are the questions? I'm not able to see.
If you scroll up a little bit, then here,
Okay.
just at the top of that, section. Kind of
Okay.
around here.
If you have a large arrays, how do you insert and delete efficiently? So it depends. Like, let's say, if you know the first of all, if you are calling in the for loop, you are doing a delete from array, it will create a yeah, dynamic memory allocation. So it depends. Like, how do you want to use? What is your output? Well, let's say you have only one output, or if you have a two output, you need to efficiently how to use how you can use is like maybe in the one of the example what I have showed is like still I'm reusing the input arrays, but output size is still the less element. So after the loop only, like better to subset it, not within the loop. Even if you're talking about this question, right, I'll recommend try to come up with a logic that you can do a array subset or delete from array outside the loop, not in the loop. Okay. Here also, like what I have learned it from my like in the experience, like if we know how to play with indexes, right, there is a different way we can play with the indexes. And with the index array, how to play with the index and replace from array, then I think all the logics you can build it without using even delete from array or even insert into array. Could you use queue for lossless data communication instead of a notifier? Lossless in DVR example. Ah, then definitely if you need to have a queue, right? You can use it for lossless data communication. You can maintain different ways. Even you can use a queue as a notifier by making the size one also. Does I have answered all the questions or I have missed anything? I am done with the presentation. If any other questions, I can take it.